Alright, welcome. In this video, we're going to be talking about AP Precalculus Free Response Question 2, which is all about modeling a non-periodic context. And because the free response for this class is totally prescribed, I just want to run through the information that they give us in the course description about what they're going to ask us about this question. Okay, so we're going to start by being presented with a real-life context. And then in part A, you're going to use the given information, which is generally 2 points, sometimes 3 in the event that we use a quadratic model, to construct a function model. That's going to be the first thing we do. We're going to construct a function model. Then in part D, we're going to calculate, apply, and reason with average rates of change and their units. Okay, so that's going to be a big thing, this average rate of change and then the idea of a secant line also. And then in part C, we're going to justify a conclusion about assumptions or limitations of the model. And that's always going to be the trickier part, but on that one, I have to show you we're just going to do the best we can, answer it as, with what we've got, and that will be enough. And since this free response question allows the use of a graphing calculator, we're going to want to, just go ahead and get ourselves a graphing calculator out right now. So the first example, and I'm just doing the best I can to get the prompt and the calculator and some space for me to write on the screen. Kind of having trouble with that, but I really don't want you to try to cram your work in amongst these questions. The way we put them down on the paper, I don't think is very conducive to you, like, spreading out your work, and just cramming in work amongst the problems is not high quality enough for what I expect from you as an AP Precalculus student. So I'm going to model what I expect, and that's us working off to the side on maybe a separate sheet of paper or something. All right, so the first one is a petition online to attempt to push the start of the school day back 1 hour. Okay, they're going to give us 2 data points. T equals 3, 4,000 signatures. And at T equals 7, 23,000 signatures. Okay, so that's going to be telling me, okay, S of T is the number of signatures, and it's an exponential model. Okay, and I see that from right there, at A times B to the T. So what I'm going to do immediately is kind of write down the data points I'm given before I even start in working this question. So S, okay, I was kind of hoping for blue on that. S of 3 is going to equal 4,000, but S is measured in thousands, so I'm just going to say S of 3 equals 4, and S of 7 equals 23. Okay. Part A is going to ask us to write and 2 equations that can be used to find the values for constants A and B in the expression for S of T. Okay, well, for S of T equals A times B to the T. So what I'm going to be doing is just plugging in 4 and 23 for S. So 4 is S when T is 3. So A times B to the third. And then when T equals 7, S is 23. So 23 will equal A times B to the 7. Okay, now, in this class, already, earlier in the year, we solved this type of system by dividing the second equation by the first and going through by hand without using a calculator. But now we've got a calculator at our disposal, so we should probably use it. And my recommendation in this case is to just run a regression. So that's going to be a 1 right here. Let's see, I'll just squeeze that in, and then 2 is going to be we're going to find the values of A and B. And I would just recommend running a regression. So we're going to go to the stat menu, edit the lists, type in 3, what was not a 3, 3 and 7, and then the output values that correspond to 3 and 7 are 4 and 23. We're going to stat calculate an exponential regression. Okay. X list, Y list, no frequency list, never a frequency list in AP Precalculus. I'm going to store my regression equation just in case I need to use it later, and then I'm going to calculate. Okay, so then it's just going to give me the values of A and B, and I think this is going to be the way to go. So 1.077, and B is going to equal 1.548 or 1.549. Okay, and because A is positive and B is greater than 1, I do know that I'm looking at an exponential growth situation. Okay, so that's part A. Part B, we're going to use the given data to find the average rate of change in the number of signatures in thousands of signatures per day between T equals 3 and T equals 7. So notice that's where we're going to be using the two data points again. That's the exact same two data points that they gave me originally. Remember, average rate of change is slope of the line that connects the 2 points. It's rise over run. So that average rate of change is going to equal S of 23 minus S of, wait, no, not S of 23. 23 is not an input value. It's S of 7 minus S of 3 divided by 7 minus 3. Y2 minus Y1 over X2 minus X1. And that's going to equal, S of 7 was 23 minus 4 over 7 minus 3. And, it's going to want it to be a decimal approximation. Show the computations that lead to your answer. That's what I just showed right there. So I'm going to go back to the main menu. I'm going to call for a fraction bar. And this one's, easy enough. 23 minus 4 divided by 7 minus 3. I know that's 19 over 4. Okay, but in other situations, the numbers might not be as nice. And I recommend just calling for a fraction bar and, typing it in just as you see it. And if you want to do a decimal, I didn't actually say it out loud, but you can go into the math menu, ask it to convert to a decimal, and then get 4.75. I'm going to write the units, even though they already told me 1,000 signatures per, day. Okay, and evidently my cat had something to say about that. But we're going to need to use that later on. So that's, maybe part 1 here. Okay, B2 is going to be, what is going to happen with B2? Use the average rate of change found in part 1 to estimate the number of signatures in thousands at time t equals 13 days. So what I'm going to do is I'm going to start off at t equals 7. So to give you kind of a picture of what's going on here, we know that t equals 3 and t equals 7. What's happening? We kind of fit an exponential curve in there. Okay, and that's nice, and we can plug in on that exponential curve to predict the number of petitions at time t equals 13. But we can also just use the average rate of change, because the average rate of change, wrong menu, that's giving us the slope of the line that connects these 2 points, right? But we could just keep going with that same line and extend the process and, get ourselves a prediction. And that's pretty much what we're going to be doing. So right here, we have S of 7. We've got an average rate of change, and so our predicted value for S of 13, well, we just say, all right, it's going to be approximately equal to, and you can barely see that on screen, I know, so I'm going to probably take that off to the side. So I'm going to say, all right, S of 13 is going to be approximately equal to S of 7, which we knew was 23, plus that average rate of change, 4.75 thousand signatures per day, times the number of days that elapsed, right? 7 to 13, that's 6 days. So I would have expected we increase 4.75 times 6,000 signatures. So that's going to be approximate. Do they actually want me to, express my answer as a decimal approximation? S of 7 was equal to 23. So I'm going to do 23 plus 4.75 times 6. And I'm going to get 51.5 thousand signatures. And that's what we did. We showed the computations that led to our answer. I'm not totally sure what they're looking for because, we still haven't seen the free response scoring guidelines for this course, besides the ones for the one example that they showed us. Consider the average rates of change of S from 7 to P, where P is greater than 7. Are these average rates of change less than or greater than the average rates of change from t equals 3 to t equals 7 days found in B1? Well, I'm going to just kind of get rid of that whole discussion because if I want to do B3, I'm going to need to think about the average rate of change from 7 to some unknown time in the future. Now that's pretty vertical, but maybe you can just assume it's not exactly vertical. I'm going to use blue, just switch up the color. This is going to be time t equals p, where p is greater than 7. And I'm going to think about the average rate of change between those 2 points. And that would be, something that's represented by the slope of that line. And see if I can get it over here just right. That's a little nicer. And see that that blue line has a steeper slope than the red line. So I'm going to say, all right, for part 3 of B, are the average rate of change greater than or less than the average rate of change from 3 to 7 found in part 1? I'm going to clearly answer the question with a greater. And then my reason is going to have to do with the concavity, right? The fact that the rates of change are increasing. Now, I don't know exactly how much reason we have to give, but I just want to be safe. Okay, I kind of ran out of room on that page, but I'll just keep going. Greater because it's an exponential growth, right? It's concave up. So S of t equals a times b to the t, and that's why I mentioned earlier that a is positive and b is greater than 1. Okay, so that means exponential growth. And in this class, exponential growth with a positive leading coefficient is enough to justify the fact that the graph of S is concave up. And then from there, that means that the rates of change are increasing. And if the rates of change are increasing, then a later rate of change would be greater than an earlier rate of change. And that's what I'm going to say for that. Okay, that was part 3 of B. Then we've got part C. And it's going to say, all right, for which t value, t equals 6 or t equals 19, should the students have more confidence in when using the model S? And now in my class, students were like very confident on this, like definitely 6 because it's in between the 2 data points. It's interpolation, which is safer than extrapolation, which overall is true, but that's not going to be a reason that's in the context of the problem. So what I would suggest we do, I stored that regression equation for a reason. T equals 19 is really far into the future. Let's see what using the model would give us. Using the model, S of 19 equals, okay, well, I'm just going to go and call for y1, which I can get from the variables y variables function menu, y1 of 19. And we're going to get 4,372.516 thousand signatures. And that's over 4 million signatures. That's not realistic for a petition to push back the start of the school day. And so I'm just going to say which is not realistic. Okay, and that's free response question 2. I'm going to do a few more of these, but that's a really good example of it. I hope that later on in this problem set we've got the one that comes from the course description, and if that's not in the note set, I'm going to just do it next. Okay, yeah, that was not in this set of notes, but I think it's really important that we work the one that came from the College Board, that they're showing us this is what it could potentially look like. And I also like this one because of the log of t plus 1 thing. It's a little weird, but we'll be able to deal with it. So this one, again, this is the sample free response question 2 from the course description, so we should definitely take cues from that. All right, so students completed class, they did a year-long study to see how much they remembered over the following year. At the end of the course, they did an initial test to determine the content knowledge. At t equals 0, the score was 75. Okay, for each of the next 12 months, the group was evaluated at the end of each month to track their retention of the content. At t equals 3, the group's score was 70.84. Okay, so I can write those down there. And then I would also say, all right, well, part A is going to ask us to write 2 equations. We already know that. The key, let's see, the equation over here is its natural log, so I'm going to need to do a log regression eventually if I need to do a regression, but I'm going to show you I might not. For A1, we're just writing the equation. So when t equals 0, r equals 75. So 75 is going to equal A plus b natural log of 0 plus 1. And hopefully you see that natural log of 1, you're like, oh wait, I'm supposed to know what that is. 1 is a special power of e. 1 is e to the 0. Natural log of 1, that's 0. Okay, but we'll come back on that in a second. Second equation is going to be r equals 70.84 when t equals 3. So a plus b times the natural log of 3 plus 1, which is 4. Okay, when it comes time to solve, for the values of a and b in part A2, what we're going to do is we're going to say, I think the best way is going to be like, oh, I know natural log of 1, that's 0. So a equals 75, because a plus b times 0, that's just going to be a. And so I see a equals 75. And then I can solve for b or use a calculator for it. 70.84 equals 75 plus b natural log of 4. So I could subtract the 75 from the 70.84. And that would equal b times the natural log of 4. Well, maybe I'll just divide both sides by the natural log of 4, and that'll be equal to b. Okay, and then I'll type that into the calculator just as I'm seeing it. So calling for a fraction bar, 70.84 minus 75 divided by the natural log of 4, and I'm going to get negative 3.001. Okay, I'm not sure about that, but okay. Let's just see what I would get using a different technique. So if I go to the stat menu and run a regression, I have to be careful because look, that natural log regression, if I choose option 9, oh, well, here, I'm just going to show you what it does. It gives you a plus b natural log x, but we want a plus b natural log t plus 1. So what we can do is do a little substitution. I'm going to say let x equal t plus 1. Then my new list, my table, and that's from the other data from the other example. I'm going to need to go and change my lists. X equals t plus 1, and then we're going to do r of t plus, or r of x. So when t equals 0, x equals 1, and r equals 75. And then when t equals 3, x equals 4, and r equals 70.84. And what you'll see is if I go over here and I do 1 and 4 versus 75 and 70.84, and I run that natural log regression, I should get the same thing. And that's going to be option 9. I might just go ahead and store that one into y1. I'm not sure if I'll need it or not, but there we go. And then we get the same thing, 75 and negative 3.001. And just making sure that we go back and at the end, we're like, okay, well, x is equal to t plus 1, so a plus b times log of t plus 1, that's just, yeah, a and b are going to be the same. All right, so that's how you could do it with a calculator if you like. But you can do it by hand, you can do it by the calculator. I really don't care, like I just want you to be right. Because if we go and look at the scoring guidelines for these, which I will after this example problem, we'll see that you're either right or you're wrong, and you're not going to get 1 point for the value of A and 1 point for the value of B. It's 1 point for having them both correct to, 3 decimal places if necessary. Okay, so that's part A of this one. Part B, use the given data to find the average rate of change. That should not be a surprise. It's going to always be like that. B1 is going to be, doing some rise over run, which is good practice. So we do that a lot in AP Calculus. All right, so use the given data to find the average rate of change of the scores between 0 and 3 months. So that would be R of 3 minus R of 0 divided by 3 minus 0. So that would be 70.84 minus 75 over 3 minus 0. And you can call it just divided by 3 if you like. I just think it'd probably be best to show exactly my thought process, and that's going to go to the stat plot. That's not what I want. I want alpha y equals, get a fraction bar 70.84 minus 75 divided by 3 minus 0, and I'm going to get negative 1.387. And what are the units? Points per month. Okay, B2 is going to probably ask me to reason with that, interpret the meaning of my answer from 1 in the context of the problem. Okay, so interpreting an average rate of change. Okay, I'm going to need another page eventually. Remember that this is an average rate of change, so I'm going to start my meaning with on average. What is R representing? The score is, and I'm going to just say changing so we can just use that value, right? If it's positive, we could say increasing, and if it's negative, we could say decreasing, but what I don't want you to say is it's decreasing negative 1.387 points per month. Decreasing negative, like let's just not talk about double negative situations. We'll just say changing, whoops, you could say at a rate of, but I'm just going to say negative 1.387 points per month. And to make this answer as good as possible, I'm going to identify the time interval for t in, 0 to 3 months. Okay, then, yeah, that was the interpretation. Then we're going to consider the average rates of change of R from t equals 3 to t equals p months where p is greater than 3. Are these rates of change, average rates of change, greater than or less than the average rates of change from 0 to 3 found in part 1? Explain my reasoning. Well, I think this might be a situation where it would help for me to look at the graph of the regression equation. And I'm realizing, okay, it didn't show it to me, but I should remind you that if we want to do that, we can go to y equals, turn on plot 1, and then zoom to the stats, so zoom 9, and then it'll show us the curve. And that would be particularly useful to us because we would need to know, basically because the coefficients, the sign of them, I think A is positive and B is negative. We found, yeah, A is positive and B is negative. The graph is going to be concave up, right? Because this is a negative logarithmic curve or whatever. But I'm just going to say for B3, I'm going to draw the picture of the curve, even though that really can't be my reasoning. Okay, so 0 to 3, say that's here. And we found that the average rate of change was negative, and that represented that slope there, that negative slope. And then if we think about time p, where p is greater than 3, so this was basically, okay, this is the curve R, this is time 0, and that is time 3. Okay, so for time p, where p is beyond 3, we just choose some time after 3, draw an average rate of change, and we'll see that it is, oh man, is it less than or greater than? Well, you might think it's less than because it's a shallower slope, but think about it. It's less negative. So it's actually a greater slope. It's closer to 0. Okay, so what I'm going to say is, I'm going to say it's a greater slope. Or greater, or just answer directly with greater, just like I did on the other one. Okay, my reason is going to be the graph of R of t has a concave up graph. I can give a reason. I don't know if we need, I somehow doubt that we need that, but because A is greater than 0 and B is less than 0, and really the fact that that causes concave up, that's totally calculus, right? But we can't prove that. We don't know calculus yet. We're going to know that just in a few months. But for now, we're just going to say that's the reason. And concave up, so average rate of change is increasing. Okay, and then C, the leaders of the study decide to use model R to make predictions about the group score beyond 12 months. For a given year, model R is an appropriate model if the group's predicted score at the end of the year is at least 1 point lower than the group's predicted score at the end of the previous year. Okay, how many years is model R an appropriate model? I actually think, I did not see any in the homework where this was a necessary thing to do, but I want to see when does R stop decreasing by at least 1. And I think that the table would probably be the best place to go for that. So I'm going to go into the table. Table. There we go. T equals 0, that's an error, right? Because we can't be plugging in, wait a second. Oh, yeah, okay, so this is not exactly right. Yeah, I should probably go in and change that to T plus 1 if I'm going to use the table. I'm going to also look and see what I did this summer when I worked this problem for the first time in the Summer Institute. All right, so there we go. We've got 70.84 going on time t equals 3, 75 at t equals 0, 69.6, 69.1, wait. Oh, for the end of the year. So I'm going to change the table settings to jump by 2, not window, but table set, or jump by 12. Start at 0, and so yeah, that's why they said 12, 24, etc. No. Okay, if you're graphing and you don't want it to graph, act like you're turning the calculator off, and that should work. Now we're talking 67, 65, 64, 63, 63.3 to 62.6. That did not decrease by 1. But I'm noticing it did not decrease by 1 here, right? When I went from 64.1 to 63.3, I didn't need to go to 63.1 to have decreased by 1. So, let me think about what it's saying. The end of the year. All right, so at the end of 48 months, I'm no longer decreasing by 1 point. So I think it's just going to be 3 years. Give a reason for my answer. Okay, this I should be able to give a pretty coherent reason. So I'm going to say 3 years. And my reasoning is that r of 48 minus r of 36, we found that was less than, the absolute value of the difference between these two was less than 1. There we go. That's what I'm going to say. I will go back and look right now. Okay, I could not find my work from this summer. I must have worked it on papers, and I thought I worked on the same tablet, but we're just going to move forward and look at the scoring guidelines for this problem, right? So we just did this problem. We wrote down the two equations, and then we found the values of A and B. And so, nope, there we go. 1 point for the two equations, 1 point for the values of A and B. What I find interesting is it appears to me, based on this, that we don't have to simplify our answer on that part. But I would personally definitely do 0 plus 1 and 3 plus 1 because this is AP Pre-Cal and they seem very serious about their simplification. B is, okay, 1 point for the average rate of change, negative 1.387 points per month, 1 point for the interpretation, and the answer with the explanation, okay, average rates of change of r from t equals 3 to t equals p are greater than the average rates of change from 0 to 3 because r is logarithmic and decreasing, the graph is concave up, therefore the average rate of change and points per month are increasing. Yeah, rates of change increasing because of the concavity. All right, and 1 point for that answer with the explanation. But not really any detail about what kind of explanations hit that mark and what don't. Okay, here we go. Interesting. So they did end up doing something very similar to what I did. We found that it was year 4 is the first year in which the model is not appropriate. Model R is appropriate for the first 3 years, t equals 0 to t equals 36. Now, I don't know if, I'm kind of now starting to wonder if, I kind of needed to have these that like, oh, it was, for the first 2 or 3 years, the difference was still greater than 1. I somehow don't. I think probably what you really need to have to hit the mark for this one is that difference being less than 1, at least in absolute value. And that was kind of what I saw once I realized it was like, oh, it's a negative number. It's definitely less than 1. But that's the scoring guidelines for AP Pre-Cal free response question 2. I've got a couple of more. Oh, wait, whoops. That's this one right here. I got a couple more examples in the notes book, and I think I'll come back with those as just a separate video. So that's going to be all for this video. Thanks for watching.